This is 4.4b in college algebra, doing a little more with the complex numbers. We discussed complex conjugates just a little bit last time. Conjugates, again, when you have the same quantity, but the sign between them is different, right? So we are multiplying conjugates together here, and they're not just plain old conjugates, they're complex conjugates, because you got a real number and you got an imaginary number combined together in an addition or a subtraction problem. So that's a complex number. So when you want to take a binomial times a binomial, you're supposed to FOIL. But when you multiply conjugates together, what happens when you FOIL it all out? Well, let's find out then. Let's FOIL it out. First terms times each other, what do you get? 16. Outside guys times each other, what's 4 times 5i? Positive 20i. Hey, what's the inside guys times each other then? What's negative 5i times 4? Oh, negative 20i. And then when you take the last terms times each other, you get negative 5i times positive 5i, which is negative 25i squared. First, here's what we should notice since we just multiplied conjugates together. Outside, inside. What happens every time when you multiply conjugates together with your outsides and your insides? They add up to be nothing, right? They add up to be nothing. So you do not need to FOIL these out. You take the first terms times each other, and you take the last terms times each other. Uh-oh, there's I squareds in there. You just told me what I squared was again. What's I squared? It's negative 1 times negative 25. What does this term turn out to be? So I cross him out and put plus 25. And this, again, you said was nothing, right? So those cancel each other out. You got 16 plus 25. What's 16 plus 25? 41. What kind of number did you get back? Real number. On number 25, these are complex conjugates, correct? There is no need to FOIL them out. First terms times each other. 11 times 11. 121. Last terms times each other. 4i times negative 4i is how much? Negative 16i squared. I want you to write that down as a negative 16i squared. Then we need to simplify him because there are I squareds in there. I squared is negative 1 times negative 16, which cross him out and put what above him? Plus 16. Cool? Add them up. 121 plus 16 is 137. When you multiply complex conjugates times each other, you will always get a real number back. So that's the whole idea of these problems down here. Make yourself a little note. For a complex number to be proper, you can't have an I in the denominator. It's very much like when we were simplifying our radicals. You can't have a radical in the denominator. You can't have I in the denominator of a fraction either. So we've got to get rid of the imaginary part in the denominator. Hint, hint, hint. How did we get rid of the imaginary stuff? Well, we multiplied conjugates together. Didn't we get a real number back? It got rid of the imagination land. So the real trick to these, there's not very many examples, and we can do more if we need more, because there's only 6. But you got to look downstairs. Oot. Bad news down there. You got some I's. You also have to realize how many terms are down there. Is that 1 term, or is that 2 terms? That guy down there. 5i. 1 term or 2 terms? That's just 1 term. There's an easy way to get rid of the i's when that's down there. We don't need to multiply by the conjugate. If you know what this is, that will help. Do you know how much I squared is? I squared is how much? Which is a real number, correct? All I want to do is somehow turn this into having some I squareds. So what if I just took it times I? If I multiply the denominator times I better multiply the numerator times I also. Oh, goody. How many terms are in the numerator? You better group them and take that times I also. Just like when you simplified a radical. If you had 3 over the square root of 2 and you simplified him. Didn't you take that times radical 2 over radical 2, if my pen would work? What's this blue number really right here? How much is that blue number? What's 5 over 5? 1. What's radical 2 over radical 2? We're taking it times 1, right? So you've got to do the same thing to the numerator and denominator. What's I over I? It's 1. Right? I'm keeping this the same value. But since there's more than one term here, you have to group them. If you don't group these things, that's a lot of points lost on your test, because it's just not cool to put 4 plus I times I and take both terms times I. All you're trying to multiply together when you write it like this is these guys. You have to take the entire numerator times I, so you distribute the I through. So let's do that. Numerator, let's distribute the I. What do you get up here? What's 4 times I? 4I. And then distribute right here, plus I squared. You cool with what I did upstairs? Downstairs, you just got monomials, right? You don't need to group. You can if you want to, but there's no need to group it. That's only one term right there. So you take 5I times I and get how much? 5I squared. Cool. Now it's time to clean up, because there's some I squareds involved. So upstairs, this guy can't clean up. He's 4I. This guy can clean up. What's I squared? Minus 1. And downstairs, you've got 5 times I squared, and I squared is negative 1 again, right? So this is really minus 5. Ta-da! Mission accomplished. What's downstairs no longer has an I with it. I know it seems weird. It's like, who cares if there's an I in the denominator? It's just part of the rules that says you can't have I in the denominator. You can have him upstairs. That's cool. You can't have him downstairs. Now, we have to put this in A plus BI form. This is not an A plus BI form. So, let me get rid of that box around there. I'm going to write, that's not a pen. Let me get rid of that box around there. I'm going to write this out. You don't have to do this, but check it out. If it's 4I minus 1 all over negative 5, would you agree that that's the same thing as 4I over negative 5 and then minus plus a negative 1 over negative 5? Right? You can split the fraction up, right, because they're all over negative 5. Yes? No? Okay. So that's what we're going to do. We're going to split it up. What's this turn out to be, though? What's negative 1 over negative 5? Positive 1/5. And is this in A plus BI form? 4I over negative 5 plus 1/5. Is that in A plus BI form? Who comes first in A plus BI form? What kind of number is A? Real number. Does the real number come first in this situation? So we better switch it around. What does it need to say? 1/5 plus, don't say plus negative 4/5 I. So instead of plus, how much? Minus 4/5 I. Keep the I on the side also. Don't put him in the numerator. A plus BI. That way you can recognize that A is 1/5 and B is negative 4/5, and there, of course, is I. So what did I do? I got rid of the I in the denominator. There was only one term down there, so I just took him times I, right? Because when you take that 5I times I, you'll get an I squared out of that situation. Cool? Totally different than this one. Why is he bad? We've got an I in the denominator. How many terms are in the denominator, though? One term or two terms? Two terms. I can't just take everything times I. Just watch me for a second. I can't take everything times I. It's not going to do the job. If I multiply by I over I, this would become 2I squared over 3I plus 6I squared. This will change to be negative 6, but oh no, don't you have a problem? There's still an I in the denominator. What we need to do, since that's more than one term, is multiply by its complex conjugate. Because don't complex conjugates always multiply together to be a real number? So, who's the problem? 3 plus 6i. We need the conjugate of 3 plus 6i. What's the conjugate of 3 plus 6i? And it's got to be in parentheses, 3 minus 6i. Since I'm multiplying it on the bottom, I also want to multiply it on the top to keep this number balanced. I'm taking that original problem times 1. 3 minus 6i over 3 minus 6i, still the number 1. But the reason why I chose it is because this dude right here times this dude right here, since they are complex conjugates, it will turn out to be a real number every single time. So let's do it. Let's do that denominator first. That's the easy part. Put a fraction bar. You don't need to FOIL that out because they're conjugates. You just have to do the first terms times each other and the last terms times each other. So first terms times each other is how much? 9. Last terms times each other, 6i times negative 6i would be minus 36i squared. Cool? Let's go upstairs. I've got a monomial times a binomial. You need to distribute. So don't we need to take 2i times 3, which is 6i, right? And then 2i times negative 6i, which is negative 12i squared. Everyone comfy with what I've done? Time to go change all the I squared stuff. This guy, what's really going to be right there? Plus 36. Correct? This guy, plus 12 total. Awesome sauce? Now, let's rearrange him. Okay? My denominator is how much? 9 plus 36. Winner, winner, chicken dinner. No more i's in the denominator. Numerator, what order do you want them to be? Reals first or imaginaries first? What order do you want them to be in? Reals first. So let's do 12 plus 6i. Then we got to separate them out and reduce our fraction if possible. I need to do 12 over 45. 12 over 45 can reduce. If you don't even know how to do that, let me show you in your calculator. As soon as I find my calculator, you type in 12 divided by 45, and you get this. How do you change it to a fraction? Math, enter, enter. 4/15. What number went into both of them then? If the 12 became 4, what number went into both of them? 3. So that's 4/15. What kind of result will this second guy be? Will he be positive or negative when you have a plus 6i over 45? Will it be a positive number or a negative number? 6i divided by 45. Positive or negative? Positive. Reduce it. What number goes into both 6 and 45 evenly? Does 3 go into them again? Does 3 go into 6 evenly? How many times? 3 goes into 45 15 times. That's what we just did again. And there's an I next to it. That's in A plus BI form. There are no I's in the denominator. Weird process. Helpful, helpful, helpful when you get to further advanced math if you ever go there. Next guy. There's an I in the denominator. Will I need to multiply by the complex conjugate? How many terms are there? 2. So I need to multiply by the complex conjugate. You have to put parentheses around anything with more than one term to keep it correct, though. What is the complex conjugate of 3 plus I? 3 minus I. Do it to both the numerator and the denominator. Cool? I don't care where you start first, numerator or denominator. Let's start upstairs. It's just a 5 times all of this stuff, so that's a distributive property deal. That'd be 15 minus 5i, right? And you've got to understand, to save yourself a million minutes of time, that the bottom are conjugates of each other. That's the whole point. Don't FOIL it out. First terms times each other, last terms times each other. What's first terms times each other going to be? Last I times negative I minus I squared. Correct? Time to get rid of all the I squared stuff. Boot! Right there. What does that turn out to be? What's minus I squared turn out to be? Plus 1. Right? It's a minus minus 1, which is a plus 1. So this is really 15 minus 5i all over 10. Now let's reduce it. 15 over 10 minus 1/2 I. right? You with me on reducing that? 15 over 10 is 3 over 2. 5 over 10 is 1 over 2. It was negative due to the fact that this was a negative number. Yeah? Next one. Problem. I in the denominator. Do I need to multiply by the complex conjugate? It's only one term. So all you need to do is take the shortcut, baby. Take it times I. A lot of people end up multiplying by negative 2i, which that's fine. You can do that. You're just like, oh, if that's a 2i, I'm going to multiply by negative 2i. It'll still work out for you. You're just going to have to really reduce your final answer when you're all said and done. Taking it times I will solve our situation, because when you do your denominator, you got 2i times I, which is 2i squared. We like I squared because that's a real number. It's negative 1. Upstairs, you have to group that, so you distribute the I. So 7i minus 13i squared. Cool? Change all your I squared stuff. This becomes plus 13. This becomes minus 2. Does the real number come first? Upstairs? It's supposed to come first. Does it come first upstairs? So we got to switch them around. This will be 13 over negative 2, which I'm going to write negative 13 halves, and that does not reduce. Right? I'm just looking here. 13 over negative 2. And then the other guy is 7i over negative 2. So should I put plus or minus? Minus 7 halves I. Noise? 30. Do you have to multiply by the complex conjugate? Yes. Let's do it. Should I multiply by 2 minus I or 1 plus I? The denominator is our problem. Can't have i's in the denominator. So 1 plus I, both areas, I should say. Let's do the denominator first. All right, that's a piece of cake. Do that for me. Multiply the denominator together. Don't brain fart either. 1 times 1 is not 2. First terms times each other, last terms times each other, right? Upstairs. Are these conjugates of each other? 2 plus I and 1 plus I. Are those conjugates of each other? So you cannot do the shortcut of first terms times each other, last terms times each other. Since it's a binomial times a binomial, you have to FOIL them out. So let's FOIL them out. 2. Outside would be plus 2i. Inside, plus I. Last terms times each other, plus I squared. You got to FOIL the whole mamma jamma out. Correct? Change all your I squareds now. Minus 1, plus 1. If you get 0 in the denominator, you made a big mistake. Right? You can't have something and all of a sudden it becomes undefined over there. You made a sign error if you get 0 in the denominator. Now I'll do a little combining like terms in the right order. Who do you want first, reals or imaginaries upstairs? So 2 minus 1, how much? 1 over denominator 2. Right, 1 plus 1 is really 2. Cool? That's all my real numbers. I combined him and him together. Those were my real numbers. 2 minus 1 is 1. It's over the denominator of 2. Combine my imaginary numbers. I have how many i's? 3 i's over 2. The bottom was conjugates. There's a trick. First, last. The top was binomial times binomial. You must FOIL. Please do 31 with your pal for me. Pause the video. Give that one a shot. I had to multiply by the complex conjugate of this, which is 2 minus 3i, so I got to do the top and bottom. Got to FOIL the top guy out. 6 minus 9i minus 2i plus 3i squared. He becomes minus 3. This guy, first terms times each other is 4. Last terms times each other. A lot of people go oopsie-daisy and put minus 3i squared. You got to take the minus 3 times the positive 3 and get the minus 9 and get the I squared in there. That becomes plus 9. Your denominator is 13. Put your real numbers together. 6 and negative 3 is positive 3 over 13, negative 11i over 13i. Let's do one more. So where you got room, let's call this 2 plus 4i over 6 minus 3i. Let's do one more of those. Pause the video, give this one a shot. Interesting thing happened when you multiplied by the complex conjugate, which is 6 plus 3i on both top and bottom. You FOIL this puppy out, and when you combine your like terms, your real parts add up to be nothing. So you still got to put it in a plus bi form, hence instructions. So you have no real parts, even though it's over 45, you know. Then you have 30i's over 45, which reduces to 2/3 because 15 goes into each one of those puppies. Cool. If there's 2 terms down here, multiply by the complex conjugate. If there's 1 term down there, just multiply by I. That is, of course, if it had an I in the denominator. Is there anything wrong with that? Nothing wrong with it. No i's in the denominator. Can it reduce, though? 8 over 2, 2 over 2, couldn't that totally reduce, right? But realize, if that was a 3 or something, there's nothing wrong with that, because the rule is you can't have i's in the denominator. Before we get to the backside, which last year was a major disaster, I'm going to try to explain it better before we even flip our page over, okay? 4 basic facts, which please don't go to the backside yet. You have to understand that. We're going to do what's called the powers of I, and I was trying to hint with you last time, and it's not proper to have a final answer with I to any other power but 1. So, number 1 thing, there's 4 things you have to memorize. Here's number 1. That I is just plain old I. Cool? It's like, duh, I is cool. You can have an I in your answer. It just can't be in the denominator. The second thing, which you already have memorized, is what I squared is. Do you know how much I squared is? It's how much? Negative 1. Now there are 2 new concepts that you kind of have to go back to know your rules of exponents, which seems weird that we're doing that in the next chapter instead of now. But the third thing you have to memorize is what I cubed is. I cubed needs to be memorized. Okay? Let me explain it to you. Would you feel that I cubed is the same thing as I squared times I? Yes or no? Like, is x cubed the same thing as x squared times x? Right? Remember when you add your exponents together and do all that stuff? Like x to the second times x to the first is x to the third, right? I to the second times I to the first is I to the third, correct? Cool. Anybody know how much that is right there? What's I squared? So would you also agree that this is really, the same thing as negative 1 times I, correct? So this guy is what we're looking for, because does it have I to the first power in it for a final answer? Your final answer can't have any i's in it unless they're to the first power. I cubed is negative I. Right there, baby. That's the third thing you have to have memorized. I cubed is negative I. And the fourth thing, take a guess what it is. This is I squared, this is I cubed. Take a guess what this one's going to be. I to the fourth, right? I to the fourth will be, we want to break it down into things we like. We like him. We like him, right? Couldn't I write it as I squared times I squared? Would you agree that I squared times I squared, you're supposed to add the exponents together, and that's really I to the fourth? Yes or no? Right? How much is I squared again? So you got negative 1 times negative 1. What's negative 1 times negative 1? It's 1. I to the fourth equals 1. So if you were taking notes, here's the 4 things you need to memorize. Number 1, I equals I. Number 2, I squared equals negative 1. Number 3, I cubed equals negative I. And number 4, that I to the 4th is 1. Cool? Question for you. Out of all 4 of these, who do you think will be our favorite one? Which one do you like the most as a number? I, negative 1, negative I, or 1? Which one do you like the most? 1, right? I to the 4th is our best friend because I to the 4th is 1. So if we go to the backside, that's what all of this is right here. It says I to the 1st is I to the 2nd is negative 1, I to the 3rd is really negative I, and I to the 4th is really 1. Cool? But they're going to give us all kinds of powers of I, like I to the 5th. Hey, man, that's not part of the big 4, right? These are the big 4. Well, we'd have to do the same old trick to him. We need to break him down. And who's the cool guy? Him. He's the cool guy. How could I rewrite I to the 5th with I to the 4th in them? It's really I to the 4th times I. Well, how much is I to the 4th, baby? I to the 4th is 1. So this is 1 times I, which is how much? It's I, baby. I to the 5th is really I, because wasn't there an I to the 4th in him? And how much is I to the 4th? 1. Cool? I to the 6th will be next. I to the 6th, I want to break him down to be I to the 4th times I squared. Y'all cool with that? How much is I to the 4th? 1. There's a chart here that you should probably be filling out on the back side. I to the 4th is 1. Do you see the big, did I get that chart on there? Yeah. Oh, it's still there? I got you. My bad. I to the 4th is 1 times I squared. How much is I squared? Negative 1. What's I to the 6th turn out to be? Negative 1. Cool? Let me see if I can explain the shortcut first. How many times does 4 go into 6 evenly? 1 time, right? 4 goes into 6 evenly 1 time. Is there some stuff left over? How much is left over? 2, right? This was really 1 times I to the 2nd. Because didn't 4 go into there 1 time evenly, right? And how much was left over? 2. This is the same thing as I squared. But do you know how much I squared is? I squared is negative 1. Cool? This is I to the 7th. How many times does 4 go into 7 evenly? 1 time. So you'd have an I to the 4th. And how much is left over? How much is left over? 3 is left over. How much is I to the 4th? It's 1. So this part never matters because it's just going to be 1 times I cubed. Do you know how much I cubed is? It's negative I. So I to the 7th is really negative I. I to the 8th. How many times does 4 go into 8 evenly? 2 times, right? How much is left over? 4 goes into 8 how many times? 2 times, right? How much is left over? 8 divided by 4 is how much? 2. 2 times, right? What's your remainder? Was there any other numbers involved? Like here's what I'm trying to do. Before I did this, 4 divided by 6. That's not a divide by, that's a radical. 4 divided by 6, correct? Didn't you say 4 went into 4 1 time? How much was left over? Remainder 2. You with me on that? That's 1 remainder 2. Then I did 4 divided by 7. Keep putting radicals. How many times did 4 go into 7? 1 time. Bring the 4 down. What's the remainder? Come on, pen. Remainder 3. Wasn't there 3 left over? Now I'm going to do 4 divided by 8. How many times does 4 go into 8 evenly? 2 times. Take 4 times 2 and you get an 8, right? What's the remainder? Nothing. There's nothing left over, correct? So I to the 8th is what we were trying to do. Would you agree that that's like I to the 4th times I to the 4th, correct? Well, what's I to the 4th? How much is I to the 4th? 1 times 1, which is how much? Ho, ho, ho! We got a 1 back again. Then if we keep doing that, you'd get I to the 9th, which it's I to the 4th. It went in there twice, right? Then there'd be 1 more left over. Don't write this down. Write this down. Here's the trick. I'm starting to lose some people. And they're just like, I'm lost. Here's what you need to do. Find out how many I to the 4ths go into the term. We need to find out how many I to the 4ths go into the term. Then use the remainder as a power of I. Find out how many I to the 4ths go into the term. Then use the remainder as a power of I. Back to what we were doing. They want to know what I to the 40th is. Holy crap! I don't want to rewrite that as I to the 4th times 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 I to the 4th. Because doesn't 4 go into 40 10 different times, correct? I counted it out 10 times. It'd be I to the 4th, which is how much? 1 times 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 1. How much is that? It's 1, right? How many times does 4 go into 40 evenly? Your job is to divide 40 by 4. What do you get? 10. And what's the remainder, baby? How much was left over? 0, right? 0. This part you could give a crap less about, because that's the 1 times 1 times 1 part 10 times in a row, which turns out to be 1, correct? What you need here is this. This turns out to be I to the 0th. What's anything raised to the 0th power, baby? Punch it in your calculator. Do this. 7 to the 0th power. What do you get? That's not a calculator. 7 to the 0th power is how much? That's not a 0. It's 1. What do you think a million to the 0th power would turn out to be? 1. What's I to the 0th power turn out to be? What's anything to the 0th power turn out to be? 1. What's I to the 0th power turn out to be? 1. Let me show that to you like this. Let's see if I can get it to you again. I to the 4th times 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 I to the 4th. I'm not going to write it out 10 times. Wouldn't I write it out 10 stinking times, right? 10 times in a row. How much is this? 1 times 1 times 1 times 1 times 1 times 1. What did it turn out to be? Because how much stuff was left over? How much stuff was left over for a remainder? We had 10, remainder what? There was nothing left over, so it all turned out to be 1. This guy, how many times does 4 go into 37 evenly? Calculator! I want to take 37 and divide it by 4. How many times did 37, let me try that again. How many times did 4 go into 37 evenly? 9 times. Was there a remainder, yes or no? Dang it, that is not a calculator. There was a remainder of 0.25. These are in fourths. What is 0.25 as a fraction, baby? 1/4. So what was my remainder? 1. This is going to be, here's what it turns out. I'll do it the long way. Don't write this down. I to the 4th times I to the 4th times I to the 4th. How many times in a row? How many times in a row would there be an I to the 4th? 9 times in a row times I to the remainder, which is I to the 1st. It'd be 1 times 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 1. There was 9 of them times 1 more. I. What do you get? I to the first. There's your answer. It's all about dividing this exponent by 4. Nobody gives a crap about these because these are all the I to the fourths. And what's I to the fourth? It's how much? 1. So that's where you got all this 1 times 1 times 1. This is what you care about. I to the remainder power. I to the first. Let's try this one. How many times does 4 go into 51? Use your calculator. 51 divided by 4. Yeah. How many times did it go in there? 12 times. Nobody cares about that. We care about the remainder of 0.75. Do you know what 0.75 is as a fraction? 3/4. So how many were left over? 3. All of this stuff is going to multiply out to be I to the fourth 12 times in a row, which is 1. This is going to be I to the third. Those are the leftovers, right? I to the third. You care about the remainder and taking I to that power. Can you have a final answer of I to the third, though? No. But do you know how much I to the third is? It's how much? Negative I. Cool? And then we're supposed to put these in A plus BI form, which I didn't do for the first two because I didn't want to confuse us. This is the imaginary part. How many real parts? Nothing. Right? There were no real parts and negative I parts. 30. We care about how many I to the fourths go into him. So take 30 and divide him by 4. How many times does it go in there evenly? 7 times. With a remainder of 0.5, which is 1/2, but I don't care about halves, I care about fourths. Instead of having 1/2, how many fourths is that? Isn't that 2/4? Are you with me on that? You got 0.5 for that little decimal, which is 2/4. So what's my remainder? 2. 2/4 were the remainder. All we care about is this guy. All we care about him, our answer will be I to that power, baby. It's I to the second power. Do you know how much I squared is, though? It's -1. Then I need to put it in complex form. So -1 is a real number. I need to put the imaginary parts, which there are none. More examples. It's still fuzzy. It should be. It's a weird concept. Very, very weird. 344. Woo! I don't want to count out how many that is. I'm going to let my calculator figure it out. 344. What do you want to do to that puppy? Divide by 4. It went in there 86 times, right? So I'd have I to the fourth 86 times in a row, which is how much? It's still 1. How much is left over? Nothing. So what's my final answer? This was 86, remainder 0, correct? This was all 1 times I to the 0th, which is how much? What's anything to the 0th power? 1. So what's all this turn out to be? 1 times 1 is how much? 1. When there's nothing left over, I to the fourth went in there evenly, meaning all those multiples of 1, just you had 1 times 1 times 1 times 1, do that 86 times in a row. I guarantee you, you'll get a 1 out of this situation. Is that in complex form? So what do we need? Nice. Try this one. 501, it's like my genes. You divide them by 4. And all your real job is, I do care, but if you don't understand the whole I to the fourth is 1, whoop-de-doo. All you have to do is interpret what this decimal is right here. Is that going to be 0/4, 1/4, 2/4, or 3/4, right? What is 0.25? 1/4. So you got 125, remainder 1. I do want you to write that down on your homework. And all you care about is meow. You will take I and raise it to that power, I to the first. Which that's a cool answer because the only thing you can have in your answer for imaginary numbers is I to the first power. You need the real part, though. 0 plus I to the first. Please try the next one. I to the 83rd power. So you want to see how many times does 4 go in there, because all those I to the 4ths just kind of crap out on us. Like, nobody cares about you. All 20 of you. I don't care about you. Can you interpret the leftover? Is 0.75 0/4, 1/4, 2/4, or 3/4? How much is that? Isn't this 3/4? So you get 20 remainder 3. Awesome. All you care about is this. You write it as I cubed. You can't have that for a final answer, though. Out of the big 4, I cubed, you have memorized, or should have memorized, to be how much? Negative I. And then you put a 0 with it. I want to do 4 more before we move on to these. These 4 problems, please jot them down where you got room out there in video land and try them for yourselves. Write them with remainders and then interpret them and then come back to me. I rewrote them all with remainders already, but the difficult remainder for people is the 2. Like the first problem I gave you was 18, I to the 18th. So if you take 18 and divide it by 4, you get 4.5. Right? People are like, I don't get that. You've got to think of it as a remainder of in fourths, because we're taking out I to the 4ths. Is 0.5 0/4, 1/4, 2/4, or 3/4? What is 0.5? It's 2/4. Same thing as 1/2, right? 2/4. So this is going to be I to the 2nd power. This guy had a remainder of 2, I to the 2nd power. This guy had a remainder of 3, I to the 3rd power. This guy had a remainder of 1, I to the 1st power. Problem with these first 3, can't have them, but we have them memorized. We know how much I squared is. It is -1, add the imaginary parts. This is -1, add the imaginary parts. What's I cubed? Negative I, add the real part, and I is I, add the real part. Cool. 4 basic things to memorize. I equals I squared is -1. I cubed is negative I, and I to the 4th, he's our best friend. We used I to the 4th more than you even understand, but that's what all of this stuff was. There's all the 1s, right? It's 1 times itself 2 times in a row, 1 times itself 7 times in a row, 1 times itself 189 times in a row, and then you have some left over. So just to break the small one down, I to the 9th is the same thing as I to the 4th times I to the 4th times I to the 1st. Right? Don't all those exponents add up to be 9. How much was him? 1. How much is him? 1. How much is this? It's I, right? We took 1 times I right there. So if I did that with this guy, I'd write I to the 4th 189 times at the beginning, and what I'd have at the last guy was I to the 2nd. Cool? Now, let's do some more. Let's do this guy. Multiplying all this stuff together. Numbers times numbers, i's times i's. Let's do it. 3 times 4. 12 times -2. -24. Y'all cool with just numbers, right? 3 times 4 times -2. I to the 5th times I to the 3rd times I to the 11th. What do you do with those exponents? Add them together. So you get I to the 8th plus 11 more, I to the 19th. Is everyone cool with where that came from? Right? He's the problem. You can't have anything but I to the 1st. So we need to reduce him. We need to see how many times 4 goes into him. How many times does 4 go in there? 19 divided by 4. Right? 4 times. Who do you really care about in this situation? The remainder. So just jot him off to the side for me. 4 remainder 3. Just off to the side. You are simplifying this. That's 4 remainder 3. This guy actually turns into then I cubed. You with me? The I to the 19th is the same thing as I cubed, right? How much is I cubed? So you have -24 times -I, correct? And now the negative times negative is a positive, so isn't this really 24I right there? And you need the real part Nothing. Cool. So we changed I to the 19th to be I to the remainder. Then we, out of the big 4, we realized who he really was. Then we just simplified. So let's do that again. -6. Oh, wait a minute. My bad. I didn't read it correctly. We got this guy on the outside of parentheses, correct? So we need to do power to a power, right? So 3 has to get cubed. What's 3 cubed? 27. It's 3 times 3 times 3. And I has to get cubed. That would be I cubed. Let me slow down for you. I took 3i and cubed it. Basically did this. 3i times 3i times 3i. Isn't that what cubing something means? Take it times itself 3 times in a row. Well, 3 times 3 times 3 is 27, and I times I times I is I cubed, right? Then, so that guy's there. I need to still bring down the -2i. I haven't changed him yet. This guy came along for the ride. Nice? Now, no more exponents outside these guys, so you multiply. 27 times -2, -54. I cubed times I to the first is I to the 4th. Ha-ha! I love I to the 4th. He's one of the big 4. What's I to the 4th? 1. So you get -54 times 1, which is -54, plus 0 i's. Nice. Got to do this. These exponents outside of here. So we need to take this guy to the 4th power. If you don't know what 2 to the 4th power is, you punch him in. 2 to the 4th power. It's 2 times 2 times 2 times 2, which will be 16. I to the 4th is I to the 4th, right? 5 cubed and I cubed. Nice. You can do this however you want. Here's what I do. See you, brother. I don't care about you. How much is that? I to the 4th. It's 1. Peace out. I don't need you, right? You're 1 times all this stuff. 16 times 125. I will definitely punch that in. 16 times 125. 2,000. Is that what you got? 2,000 I cubes are right there. I'm going to just go ahead and call him -I. Right? I said nobody cares about I to the 4th. He's 1. I cubed is really -I. So isn't this really minus 2,000 i's? And you have no real parts. Woo! Not the easiest thing in the world. If you have questions, please let me know.